I mean, okay, cool. So I want you all to drive this session rather than I am putting the things across. So that is how I try to make it more interactive. So however, how do we, let's set the rule, how do we interact it, right? So either I'll keep my chat open and also I'll see the interactions like the interaction expressions what you give, right? So before we start, let me set the ground, right? So as so I've said, it is about AI. When it comes to AI and the cloud infrastructure, so there are a lot of content you can find across the internet, YouTube, right? So however, I try to drive the content, the stuff my from my practical experience, which normally I feel not available over it, right? Just to make you aware of things. Right? So just to start with maybe I start seeing the chat. How many of you know like program managers roles or the TPMs? Just say yes or no in the chat so that I'll take it at least the understanding set in the stage. No, out of 40 people, I just see only one no, no. Okay, good. Cool. So if you say no, I will cover the topic. If you say yes, I will skip the topic. This is how I am thinking to drive it. So basically, you are the driving this, the whole session, right? So basically, in your organization, between the business, your organization has the business and the technology, right? The business is basically who brings money after their spending, and the technology is the part to get that money, right? To make that money. So the program managers or the technical program managers basically works at this intersection, right? The intersection means they work both with the business teams like the CEO, CIO, CXO, CFO people. At the same time, they work with the engineering team to drive it and bring the outcomes from the technology. That is where the program manager or the technical program role falls in the corporate world. That is where I come from. So my name is Mateen. I have overall close to 20 years of experience. I work with the companies largely in the mobile domain, LG, Samsung, OnePlus, currently with Krutrim Cloud, where we have built our own private and the public cloud, both AI and the computing. Right? Let me get into the next topic. So the topic for today is okay. Sorry, let me just give me a moment. Do you able to my next screen? Okay, now it's moving. Good. So the topic for the day is artificial intelligence, the cloud infrastructure, right? When this comes in your mind, yeah, the lot of things running in your mind. There are many things. The agents coming to your mind, the open crawl or the Anthropic, the Opus 4.6 or whatever. Like lot of things comes to your mind. I'll take it this the technology in a very broader perspective. The as a program manager, I'm walking you through to the broader of the rather than getting to depth of the topic, I'm taking you to the breadth of the topic. So in this session, I'll be covering largely on the end-to-end understanding of the AI or the cloud infrastructure, not getting to specifically hands-on building an agent or and deep understanding of the how the model works and the stuff. But I'll try to cover everything across the board what exists in today AI era. So you see the technology architecture economics. If I see this from the program management lens, uh, technology is I will be little funny, but technology is something the stage where the people take money out of their pocket. Basically, this whole era, the whole the cycle is it start with the moment the people take money out of their pocket, till they reach, to take from others' pocket. This is the whole game of, the technology. Technology is not free, right? So the technology where you invest understanding a deep tech, bringing out the, the deep tech solutions, right? So that is the technology where you spend on the R&D. And the architecture is basically the path to reach that use cases. Basically, the use case is the part, how do you take back that money from the, the respective segment or the respective resources where reaching the right pockets. Then economics works, how do you, balancing, taking back the things, right? So if you see the, the era of, evolution, uh, if you see the Arab ratio, we have passed through like a different, different ages. I just putting you, starting a very breadth of it so that, get the, the mindset setting. Like, basically, I'm trying to set your mind. So where we start, where we stand now. So what are the lens you have to use, the lens you have to see for the, AI era. So one thing what I'm trying to, look out is, look out at stress on the, here is, if you see the different ages starting from the stone age to iron age, uh, the, the era has exponentially decreasing. The age between the different, two, revolutions has been drastically dropping down, like from millions of years to just an years. If you see this, the computer age, the era of, the evolution from computer age to internet age, it just the decades it has evolution happened. From, if you see the adoption of AI, internet to, internet age to the AI age, it is just couple of years. It just started, in, 2022 on November 30, when ChatGPT has launched, the first their, the end user interaction LLM model. Yeah, and, the Gen AI to this 2020, in the 4 years, the, if you see the change, it's a very rapid. And when it comes to the next revolution, I think it's more shorter. So that means we have to move if you want to be, a value add in this, ecosystem. If you want to be, meaningful in this era, you have to move very fast. That is the first rule which we have to understand. The second thing is, on the skill set, right? And, so many of you, from the different background, if I say, right? So some of is like fresh graduates looking for a job. Some of is already in the entry level job. Couple of you are in the senior executives and, the engineering manager stuff, right? So if you see the expectation, the, over this, period has been changed a lot, right? So if you see the, the industry revolution where the all the engineering like started, at the first place, right? Like doing the engineering, like, basically, the mechanical engineering or the civil engineering, the stuff which the, the industry level revolution, the concept of engineering, the building things. How do you put two gears together to move, rotate the wheel? That is where the engineering started, from the engineering, industrial revolution. And then the computer age, this, the blue collar to the white collar job. And the computer age is, basically, if you see, if you, those who are like 10, 20, 25 years of, in the, software, tech industry, you understand. In the computer age is like, if I recall, we were reading books and coding in the computer. That is how the age started. But as the things move on, the internet age, where the, the output has, the skills has was the critical role in it, right? The giving the output, the right output in the internet age was important. So what is the demand in the, what is the demand in the AI age now? Right? So is it the, so earlier, if you see, knowing the 10 12 different programming languages was a skill. Like people, proudly say that I know like 12 different, programming languages. At the same time, I used to, heard a lot of people, I wrote 2,000 lines of code in a day or 10,000 lines of code in a week kind of stuff, right? Where is a proud moment. Now this all has gone. The things has changed. The things has changed from blue collar to white collar to the output in the AI era. It's the outcome. I'm just putting again. It's the outcome what it demands. The outcome. What does it mean? The outcome is you need to understand the my first slide, which I said the technology, architecture, and economics all put together is an outcome. If you understand the technology, if you're able to put the right, part of solution, and if you, understand the economics, how do you, cycle this money, then that is the outcome. That is what the AI era is demanding. It doesn't matter. It doesn't matter how many languages you know. It doesn't matter what you don't know, what you know. It's all depends on how much you are dumb. It doesn't matter. If you are able to give an outcome for any of the thing, for any of the corner which is not seen, you are, very valuable in this era. That is what if you see around. So I hope you got understanding. If you say yes, okay, let's move on. Yes, no, yes, no. Cool, cool. So let's cool. Cool, cool. Thanks, you guys. Thanks, everyone. So let's move on understanding the AI now, right? So the crux of the AI, the first principle is the machine learning. I just to before I start talking, whether I have to decide whether to cover the ML or not, machine learning or not. Let me ask you one question: how many understand parameters, weights, and biases? Say yes or no. Parameters, weights, and biases. No, no. I'll just wait. Yes, yes. No, 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 no. Okay. Okay, cool. Let me cover the the just basic understanding of the ML. So okay. So what is ML? What is the machine learning? So if I say the machine learning is nothing but a software engineering, I'm giving a very dumb, very first principle definition to it. Okay. So traditionally in the computer age or internet age, we were the coding the logic, basically the algo. So basically if you see the 10 years back, so every company is asking your algo capability. How do you think of the logic to solve a problem, right? Think of a logic to solve a problem. That is a traditional way of software engineering. What is machine learning? Machine learning is learn the algorithm from the data. What machine does is it's learn the algorithm from the data. That means you're not writing the algo, right? You already written an algo which figure out the algorithm from your data, from the input. So if I see the very simple diagram, in the traditional, we give the input, we write the algorithm, the humans write the algorithm, and we take the output, right? And we write the logic which we know, right? And there are a lot of things which we don't know the logic. We are not able to solve the problem. That is what happening today, right? So in the machine learning, we'll just give the input output. This is my input, this is my output. You figure out the algorithm, whether it's addition, subtraction, multiplication, whatever the complexity is, right? So that is, yeah, very basic definition of machine learning. Let me tell you, as you all said, you're not aware of, the parameter or the weights and biases, right? So this whole machine learning happen over, the technology like over fitting algorithm, right? So let me get back to the very basic model. So I'm talking about the, the very, very, very basic model, right? It is a two parameter model, basically what I'm trying to explain you, right? So currently, if you see in the market, you heard of a lot of models, right? Like from the OpenAI to Anthropic to Quinn to Mistral to a lot of models, and you see the different parameters. The one thing they talk about is 7 billion parameters, 70 billion parameter, 1 trillion parameter, and more than 1 trillion parameters, right? So what is this parameter means in the system? That is one of the important criteria. So if I take this example, I'm just the best understanding of very basic understanding of ML. I'm explaining you the two parameter model here, right? So you all know that in the high school we this the function we worked on, y is equal to mx plus c, right? So what it does is we if we have the graph chart, we put the expression like y is equal to 2x plus 5. We x is a function of y. We'll give the value of x and then draw by the value of y and rather basically the graph, right? So what ML works is in this example, if you see, I don't know M and C is my the determine the learning algorithm which I have to do, right? So I'll give the value of y and x to the my machine or the software or the algorithm. I'll say, for example, I'll say my x is x1, y1, x2, y2, like that, 2, 5, 10, 20, kind of stuff, and say with these input output values, you figure out the value of m and c, right? The value of m and c. So that is the this is a kind of a in this linear equation. If you see, the m and c are the parameters to be learned by this algorithm, which is a AI algorithm, right? Here, it will try to reach to, the best fit, for this. Try to adjust the value of m, value of c to match the value of the at the given time t, right? Try to match that the best fit algorithm. This is a kind of a ML is kind of a curve fitting algorithm normally, like what industry says. So that is the parameter, the first definition, what I said, right? And the second definition is what is the weight. M is the weight. M is the multiplier where it will give you the attention to that particular the more the multiplication factor is, the more attention to it, right? So that is the the weight. You might have heard the weight and biases. That M is the weight and C is the bias, where you do the normalization of the value of y for the with a constant c, which is a bias. So this is what the AI model work like, right? So if you just extend your imagination of today's model, if you are telling your model is 1 trillion parameter model means, so basically it can solve the LLM model can solve, execute an arithmetic expression with 1 trillion parameters. That big, the expression it can solve. That is where, the overall game of GPU coming to picture, like, and the overall, game, maybe I'll cover in, the next slides. Cool. I hope you all understand the very basic. I just wanted to set the stage, not missing the thread of understanding the full stack AI layer. So before getting into the next topic, I want to get into the full stack AI, understanding the overall AI. Just one question, maybe before covering that, how many you understand or read about AI infrastructure, or like let me put it a very simple way. How many you understand the difference between CPU and GPU? Just say yes or no. What is the exact use of the GPU? Why it's all of a sudden coming to on the limelight? No, no, no. A high level. Okay, good. So let me take you the next central processing unit. Okay, good. Yeah. So AI is a five-layer cake. So basically, now you understand the cracks of the underline of the machine learning. That is how the neurologic and the rest of the thing grows. If I take the overall as AI is on the high level you categorize into five layers, right? So the first is energy. What is energy? Energy is basically an electricity, right? So why is energy is at this layer? Is it technology? No, right? I mean, electricity is not a technology. Why it still is important? Yeah. So if you just read about any data center, the capacity of the data center, if you talk about on any news article, they talk about the size in terms of the electricity power. We are building 100 megawatt of data center. We have, for example, the recent news from the UAE. You can see that Trump has announced 5 gigawatt of the data centers across UAE, and India has built 1 gigawatt of data center. So the very basic requirement at the start of this whole game is which powers these AI factories. Why it is important is, I'll just tell you one example. Uh, why is important is, to compute this high level computation, it requires a lot of energy for both one part of the energy goes for the execution, right? The GPU, energizing the GPU to compute, and the next part of the energy goes cooling down. Like that is another big altogether a tech which is standing with that is it generates a lot of energy while compute, and we have to cool down this and do a lot of different technologies like the DLC, the liquid cooling, liquid immersion cooling, and the stuff, right? That is the first layer which I'm trying to understand. Maybe I'll get you more numbers. Just keep in mind these layers. I'll little try to cover some parts, a little more parts to it. And the chip, you understand, right? Chip is the CPU and the GPUs, right? So this is GPU. Basically, the GPUs are the high computation. In CPU, if you see, it's a more like a kind of a planner as in like which organize the things, right? Which can handle more organized stuff and structure it like different threads. And the GPU is basically designed to compute the similar set of data at a very the high scale. Just to example, if you talk about the CPU has the two 128 cores, 64 cores. If you talk about GPU, it has like 10,000 cores. Means it can execute 10,000 threads, software threads at the same time, right? That is the difference. Basically on the compute side it can say. And the infra is basically there is a CPU with energy. This CPU built the servers, the AI servers, then AI servers put in the racks, and is put in the one hall, which is maintaining the cluster, do the networking and the stuff. That is kind of a AI factories, which is limelight. If you heard about the Sundar Pichai from the Google has announced 6 billion data center in Vizag. So basically the 6 billion is going into this first three layers, right? Enabling the energy, getting the chips, building the infrastructure where your model sits and do the training or inference. And then next comes as the models. I don't want to get into model side of it, since you might have heard a lot about it across the internet. So the many companies like state of art models has come. Basically you can say it's an open source model, closed source model, like different sizes, different capacity, different use case. And the front runner of these models are, you can say, like OpenAI, Anthropic, Google, Mistral, Quen, XAI, whatever it comes to picture. And then comes to the application. So applications are basically the architecture level where you are finding the path, to take, to take that ROI part of it, right? So now this also I'm not getting into it largely now. But yes, you might have heard a lot about different agents like a coding agent, image generation, video, voice, analytics, a lot, which is there in the market. Like you might have using the cursor, Go Pilot in the coding, and a lot of stuff which is around the market. Okay, so the next part is, let me, I think this is the next part I don't, I just wanted to cover because this is interesting, right? You might have heard a lot about the GPUs, right? So how does it fit into a how do you the fit into a HPC, like high performance computing machine, right? So I'm taking here one use case to explain you. I'll try to be very quick. If you have any questions, like put in the chat. I'll try to cover now, or I'll try to cover at the end. So the GPU, like the high HPC machine, is you can take the same similar like your desktop machine analogy, right? So in our desktop analogy, you have the CPU, you might have the additional RTX card into it, you have the NIC card, basically where you connect the internet, you have the RAM, right? So this has scale to the very large levels, right? So what is if you take a Hopper server, either it's a DGX or HGX bus, either it is built by the difference is like either it's built by NVIDIA, the overall solution, or by any of the OEM, Lenovo, HP, or Super my computer or the stuff, right? So what it has is the one server has 8 GPU cards, basically, right? The 8 H100 GPU card, and every GPU card has the ConnectX-7 card. Basically, it is a DPU. Basically, you heard about CPU, you heard about GPU now. The next component in these HPC machines is the DPU, data processing unit, which process the high scale data. I'll come to the numbers, right? So every GPU is connected to the one, ConnectX-7, which is a data processing unit. So to compare the values, the DPU can have the ConnectX-6 is the 400 Gbps capacity. The ConnectX-9, which is currently in the market, is 800 Gbps capacity. Just imagine the scale. You in your desktop, you're having a NIC card, you're having a NIC card, which is a kind of can you guys see my screen? Just power went down. Let me share back. I'm sharing back my screen. Just give me a moment. Just say yes or no if you guys can see my screen. Okay, cool. Fine. So I was talking about the ConnectX-7 card. ConnectX is basically it is largely made by Mellanox company called Mellanox, which is acquired by NVIDIA. So your the NIC card in the desktop has a 1 gigabit of capacity where you connect the LAN card, and when it comes to the ConnectX-7, it has the 800 Gbps of the internet traffic movement, right? So that is how this overall look like, and also it has two CPUs like normally like the grasshopper CPUs which comes into it, and also it has every GPU has the NVMe disk. Basically, it's a memory disk. It's a silicon pure memory disk which has comes like normally it will be like 15 TB of data. So just to understand you the economics of it, the overall, the 8 GPU server with, the 8 ConnectX card, this cost, close to 2.5 crore in Indian rupees. So that is how costly, the technology is, right? Just moving on to the next screen, this is just some pictures to show you how do I, from my past implementation at Krutrim Cloud, where we had maximize the slide. Okay, just is it better now? Yeah. Good. So this is just to show you guys how the real picture look like. This is the real pictures from our data center. The H100. So this is how the GPU bay look like. This is how the picture look like. So this is how when the machine runs, this is how it sound in the data center, right? This is the one rack we have the two nodes, right? So and again I'll come back to you on the energy side of it, right? So you have to basically the first three layers. If I was in the EAE the stack, I was EAE factory. I was talking about the energy. Like let's look out why energy is important. So the first, the energy side, if you see, this one CPU, okay, not sorry, not CPU, this one H100 node has the rated power of 10.5 kilowatts. Can you imagine like what is 10.5 kilowatt of power? In your home, we normally like, one home to run is like 1 kilowatt to 2 kilowatt, right? It's like a, four, five, at least with the fully, utility, two, three homes it is running. So that much power it consumes, 10 kilowatt. And the rack in a rack, if you put that rack capacity, the power consumption which I put in the numbers is around like 25, like to 40 kilowatt rack density, which we have, implemented. So this is like a, an year and a half old, the GPUs. Now the from H100, NVIDIA has evolved to H200, GB200, GB300. Now, if you talk about the power requirement in a rack, which I was telling, the one rack has two nodes, which is like, 25 to 30 kilowatt of power has increased to 165 kilowatt in the latest drop in, the GPUs. The 160 kilowatts, the Vera Rab in the Sheikh has perfectly said, like 160 kilowatts. Can you imagine how much power we needed to enable these AI factories? Okay. So once this hardware layer is set, all the GPUs, then basically we build, the basically the virtualization layer where all the orchestration happen. Whether you want to do the training, the inference where we created, right? So we have like, couple of, the platforms we build it to make it, virtually available, like CUDA drivers and the stuff which enable all the intercommunication of the GPU. For example, your workload need 16 GPUs to run, then it uses across two nodes or across it to compute all as a one cluster to run it. That is how there's virtualization layer coming to picture. I just flash you for your understanding. Once you build a hardware layer, then it comes to orchestration layer where we do those it's basically kind of the tools, drivers, and the platform in mix, where you enable the physical layer of these individual nodes to this consumption side of is like a GPU as a service or the model as a service. I just put you across one you know the one use case to make you understand how to understand the AI factory. I have used a use case of XAI data center. I put the four headers in front of you to understand the the what AI data center is, why like only the developed nation able to do it, and other nations still behind in this race. So to build is basically you have the Grok in your X application, which has AI model, right? So to train this Grok the model and the X company has built 2000 cluster GPU data center, right? This is the first data center from the XAI which has brought. And the second part is interesting is it cost you around $6 billion, right? The huge money. And the third point is, if you see the server to server communication, I said like, the every connect X7 transfer, the data between the GPU to GPU is in the speed, the speed of 400 Gbps, right? Which comes, the node to node communication is like 3.6 Gbps per server data transfer. So it's a huge, it's maybe the Nvidia CEO says the latest NVLink 72 transfer the data of whole internet speed. The NVLink, the capacity of the bandwidth is equivalent to the world internet speed, right? And the fourth important point is the power it takes, right? The power is basically, it takes 300 megawatt of power. So what does it mean is 300 megawatt is equal to, any equivalent to like 1.22 lakhs home in a in a city like Ranchi or Gwalior. So just give an analogy how much power it takes, like to just run one data center, right? So this much like a city power it takes, right? This whole game, why it's so expanding is this whole game, start with the obviously with the power enablement. Let me move on. Before move on to the next thing, so you all heard about the models, right? So how many of you heard about the pre-training? Maybe I'll just be straightforward. It's how many you understand the embeddings? Embeddings, yes or no? Yes, no. I think I need some more answers to decide to move on. Okay, cool. Cool. No, 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 no. Cool. So we covered energy, we covered the chip, we covered the inventory which comes to the EA factory. The next thing is basically the model, right? So where this whole game started of the EA. EA is the not a the neural network logic, and the ML is yeah, the ML or the neural logic is not new technology, right? Okay, yeah. So not a new technology. It's all like but it's like the whole game started maybe in 2012 when the deep deep tech has been coming to picture. The whole picture like started with the AlexNet. Maybe you read about it. The AlexNet, that is where it is trained to categorize the picture, whether it's a cat, a dog, horse, or a donkey kind of stuff. That is where the whole picture started. And then what has been come just okay. So what is the game changer here is sorry. The game changer here is in 2022 when the OpenAI used this LLM transformer model to do the reinforcement training, right? Supervision training where human can give the input output control. So that is whole like game thing started. So I'll just give a very high level walk through the kind of a the model. The model life cycle, right? So if you want to understand a model, the few things which you need to understand is the tokens, right? The tokens is basically maybe I'm not getting too deep of it. You get a lot of content across the internet. So token is basically translating the whole text into a the fixed breakdown into a smaller unit. That is a token. Basically, what is the difference between the digital logic and the neural logic is basically the digital logic is zero and ones based on the energy level. The neural logic is not zero and one. It's the transition between zero to one where it weights the value, right? So that is what it change the whole computation picture, right? And the next is basically embeddings. So with the embeddings, we put in a vector. Basically, the whole the underline the logic is all like more about the mathematics, right? So this basically one token put into a vector, basically to say that the categorizing the weights of it. For example, the very best example industry take it is a model, right? The model, if I say model can be an actor, model can be the four model can be have a different meanings to it, right? So what embedding does is, if it is a actor model, it will place in a vector with the respect to weight, which gives the meaningful meaning to that this model is particularly referring to the actor, the Bollywood Hollywood actor, right? So that is the embedding, say, vector representation of the token, basically the semantic relation, then bring into that. And then the second part of this is giving the self attention to it, right? So basically self attention is basically comes with the training, where I talk about the weights and biases, right? So that is where the weights is to give the attention to that particular the direction of the vector. Like model is basically it say that in this particular context, if you're talking Bollywood actor Salman Khan is a Bollywood actor is, then it understand you are talking about the the model in the context of Bollywood, where it will give the attention to that basically the model in that vector, right? So then it comes to the prediction and objective. That is all like to understand the model and the base layer, right? So in this you can go and read about a lot of content. Maybe basically if you need, you can I can share across. There are good videos around it to understand the basic layer of it, right? So let me move on to the to interest in interest of time. I'll try to try to cover the big picture of how the overall things works around, right? With this basic definition of the model, then it comes to the how the life cycle basically evolves around this to bring to the use case. Like now we have the AI factory, we have the model, right? So how the model converted into the use case, like the end user use case, how do we use this, right? So basically start with the pre-training. Pre-training is basically this model will give you a dump of everything to it, a raw dump without any the without any monitoring, the human intervention of training. The whole internet data will dump to it, with the whole the books of data, the research articles, everything will dump to it. That is called a pre-training stage, where basically where basically it uses the huge AI factory infrastructure to set its weights and biases, basically. So that is where it understands the common English, natural language. It will give a common understanding, a very general understanding, the language, grammar, whatever you talk about it, right? So that is a pre-training. That is where in India, if you talk about it, where we are not able to do the foundational model, basically this foundational model not able to do is, it takes a huge infrastructure, for the pre-training. So that is where the lack of maybe energy, the lack of capital play a very important role. The second is fine tuning. Fine tuning is basically we take this foundational model with the pre-trained model, I mean, do the fine tune it, right? For example, if you take the Indian, a lot of companies like the Sarvam, Gani, or Saket, or multiple companies who do their, the voice, the localization, the basically the linguistic voice conversations. It's basically do the take any Llama model or Mistral model which has Sarvam has used it, and then fine tune it with the Indian context, Indian data, understand the localization language, fine tune in the understanding different page and the stuff. That is basically like tune it for the particular use case, either maybe in linguistic or the medical use case or the the industrial use case, whatever, right? And then it will comes to the inference. Inference is basically this model we use it for actually the real use case. Basically, we deploy this model into any of the server GPU machine or GPU node, and then we'll take output of it. That is where the inference, basically we are running the trained model to get the output. And the next thing which comes in this flow is the moderation. Moderation is basically we will guardrails, using it, right? Guardrailizing, maybe we got a lot of maturity in the moderation in early days of LLM adoption. You would have seen it was like talking about making a how do we how do you rob a bank? It doesn't know that. I mean, model just with this context, it will just tell you how do you rob a bank, how you rob a bank. A good plan it can give you, right? How to make a gun, it can give you, right? So nowadays, all these have been moderated based on the policies, based on the compliance, based on the safe. That is all about the you heard a lot about AI guardrails and the stuff. Then come to the jailbreak, right? Jailbreak is basically to secure the model, right? For example, you have done a lot of fine tuning, you have put a system from the stuff where people try to get into the system, basically the hacker path, where it's called a jailbreak, right? So that is all about model life cycle. The other side, if I talk about the different models, we have the foundational model, which call like pre-trained models, which comes all the model which provided by every day there is a new model coming up from all the companies which I mentioned before. And then the lot of companies who do the fine tune, which follow the instruction what you have given. And then basically, and again, if you move on, you can see a lot of conversion and aligned multi-model small models like SLLM, VLLM, mixer of now nowadays it's more we are about talking about MOE, like mixer of models, where like general intelligence has been the benchmark, where the selective active parameters is the subset, right? So the next the breakthrough is the agentic model, right? So how why this suddenly come to the real human use case of these models? It was just generating the text. So if you take early like 2023 or like till like 24, like we are using to just interacting with the natural language, the models. Nowadays it is not, right? Nowadays it's all about the task execution, right? So how it is the whole changes? The only tweak which OpenAI has come up and do the open source is they structure that output in a way which can initiate or trigger the tool calling. Basically the tool calling is basically it can ask the database, you can connect to MCP server and say, hey, I need this data to process this further, right? So that is where all the the whole game change again happen. And the reasoning driving system where it just not give the response. If you ask something to the model, the reasoning driving system plan it what to be done. If you give a if you say like task, some particular task to do it, I want to start a the poultry farming in my Bangalore suburb, suggest me a good place and economics and the business out of it. It will say that okay, I have to do the research, I have to do the economics, I have to do the market time and the stuff. So and then it will the all the step by step it will execute. That is where agentic is coming to picture. I hope it's all good till now before I move on to the next. So do you guys need to get understanding of agent, because it's a very common topic across the internet? Say yes or no. I'll just quickly walk through agent or agentic AI. Okay, so many of them says yes till now. Any no's? Yes. Okay, there are more yes. There are still like few no's. Okay. So the agent is basically, I'll give you maybe, yeah, we are running out of time. Let me give a quick, high level understanding. The agent is basically a software engineering work rather than the LLM work, right? So why is it is orchestrating the whole the engineering to get the internet output using the LLM or the model. So what it does is model doesn't have any memory. Basically, it just take the input, it predict the next token. Basically, it will take the line and give the the prediction what it does the model, right? It doesn't understand actually to the context of it. So now what engineering does added to it is we build a chain of context to it, right? So how does it do is we write a software layer to it where we call as an agent, which what it does is it will save all the short-term memory in the same chat, the context it will save, and while giving a prompt to the user, it will give the whole context, right? And then the RAG tools, it will enable the where it will enable the multiple tools where it can use it, and then execution tools and that stuff. So basically, what the difference between the the LLM or the chat application, the agent is basically it execute the task, not just to give a predicted output. It execute means it take an action, right? Where we orchestrate based on the model output, we execute the task. So that is what we call as an agent, right? I give you a very simple example to understand is, for example, if it is a weather agent example, just as you might say, very basically a weather agent. If you ask the chat GPT what's the weather today, uh, to be if you say on the back end of the engineering model doesn't know what's the weather today. It doesn't have the data of your a sensor to sense, okay, go and check the weather and come back. It doesn't have it. What behind that scene agent does is uh, it comes to the model say that I don't know, like go and check the AccuWeather site and get the data. And model, what the agent does is it will pass the lifelong to this website, fetch the data, and then get organized. And if it is on a particular based on the geolocation, it will put a nice graph and the stuff. So that is how the whole the context window coming to picture. So just to little more example, I was just explaining the chat engine, right? So if you say any query, what it does is, it will go to the internet, okay, search the internet, bring the details, and then put it to one LLM, to think through what output we, internet output we have to give, and then it will scrape the data and then put a responder LLM, where it will give you in the proper format, whether it is a image or the bold and the different formats, right? So that is how these chart agent. I'm really quickly moving on. So I had another example of the deep reasoning agent to explain. It's a similar way, right? So this is like agent orchestration, basically look like you do the multiple LLM calls at each stage to understand to give the internet output to the user to act as an agent, right? So I'll come back to this the jobs in this. So as I said, the more you understand the breadth of thing is, it doesn't matter what graduate you are, what skill set you are, right? So to get into the industry, get into the AI, only thing is, rather than looking in the point to understand what to learn, just start learning what to solve. See the problem and try to solve through AI, rather than just try to understand more and more. Only thing is, what you need is, you need to understand the breadth of the topic and the foundational the concepts, and just go and figure out your problem, whether you are a new engineer or the working in the engineering manager or different position. Try to solve the problem. That is where you can see your fitting, where you fit. So I'll just flash this to understand. So let's move on to the the next topic. I quickly finish in a couple of minutes. So the next topic, which is like a cloud architecture, right? So the way I mentioned about the the AI layer, the same, it's a cloud layer instead of the heavy computing GPU, it's all about CPUs, storage, right? And enabling the computing machine. So this is a very high level architecture to understand the cloud. It has the multiple the compute servers, all these compute servers having the the block or the object storage, and then we'll create different virtual private clouds as it on the virtual layer. And then we enable the different the left side, if you see, it's all like a control plane services which we build. And the right side, if you see, what cloud architecture has, it I just mentioned the high level. It has the servers, which actually has the CPUs and the like the CPU memory. And the next, we have the block storage, which is a high speed storage. Basically, in AWS, you can say as the EBS value. And the third is the high performance storage, which we call as the object storage. In AWS terminology, we say as a S3 storage and the stuff. And then we have the load balancers, basically, which the orchestra, the all the incoming northwest traffic or east-west traffic within this whole the hyperscaler. And then comes the firewall and the edge network and the connectivity. So just to give you a glimpse of economics, if you're talking about the cloud, you will pay the price. Will the pay the price for the CPU and the RAM and the storage object and the block storage or the egress cost. When it's come to GPUs, it's all about tokenomics. Maybe you talk about it. When it's come to training a model, it's about how many GPUs you are using to train your model and how long you are using it, and that multiplied by how many hours you're using it. For example, just to say about, I was hearing from the Ghani CEO yesterday. So he was created a the voice to voice model. Voice to voice model is basically the model take input as a voice, give output as a voice, right? So earlier it used to be a ASR and TTS model. For example, the voice it converted to text, and then it will give LLM will process it and then will convert from the text to voice. So what was happening in the past is the the sentiments of that voice is getting lost, right? So that is where the latency was adding on. So just to back on the economics, to train this VLLM model for in the the linguistic languages of India, it has to give the voice samples of 8 million minutes of data, right? So that much data you had to train it to get the desired output in any languages. What you have seen the server demo in the AI summit which recently happened, in the real time it is translating the English voice to the different Indian languages, right? So as many GPUs you have it, you can reduce the the training time, right? So as many GPUs you increase it, then the cost will increase. Then the inference cost is basically based on the input output tokens and the model size which is coming, right? So that's all I have to talk today. Just 3 minutes over the time. So let me know if you have any questions, put in the chat, or that will be, I'll be here for another 10 minutes. Maybe I'll take up the questions based on your engagement. I'm a senior network engineer nowadays. A lot of AI engineers courses are available in. Yeah. Okay, what I suggest is basically how does this, for example, if you're a network engineer or any other domain, you're working for years in that domain. What I suggest is don't think AI opportunity as altogether a the new domain. Okay, if you want to best do is try to adopt the AI in your day-to-day work, right? In the day-to-day work, try to see how you can be a, for example, you are spending a day for planning. For example, network, if you are a network engineer, basically I assume you do a lot of network configuration or the firewall configuration or the the VPN and the stuff, right? So how do you automate these things? Build an agent around it. Just learn how to build an agent, and take your use case and adopt to it, right? Try to save your time and learn more. So that is how the things work. So if you are going to the next company, if you value yourself a AI enabled, people don't ask you to build a foundational model, or people don't ask you about yeah, out of that, right? If you say that as a network engineer, this I was doing, I had this a couple of enterprise network to set up, which was a 1 month project. I used AI to get organized and finish it in a week. That is the value add. That is what you need to learn about it. Basically, just in the nutshell, learn building an agent, take your use case, try to adopt it. Okay. So for non-IT, AI is not an IT. Let me put it very clear. AI technology is not an IT. Okay. It's not about coding. The AI is the if you want to leverage the AI era, you have to just see the corners, unseen corners. If you see anything around you, which is, yeah, maybe I'm addressing to Aparna, which you see that which you see that can be solved, just try to understand, go to any I'll suggest go to YouTube video. You don't need to do coding, right? It's all like natural language which you can build the products, right? So basically, if you are a receptionist, for example, right? So how do you leverage, how do you leverage the AI to organize all your calls in the context? For example, I'm just giving a very simple example. If a receptionist, you get a 30 calls a day, different calls, and then there are follow-up calls tomorrow. Then use the voice recording, get the analytics of it, use an AI, and give a summarize of it, right? So that next day you can follow up the same. That is how I talk, you have to be adopt the AI. Yeah, the same like paramedical industry. I'll say the very the common ground road people talking about a lot in the different domains. How do we leverage AI? The only thing which I say is, if you want to value add in your career, if you want to come into the limelight, try to solve your own problems through AI, not just end up learning and learning, right? So that is the reason in the very first slide I said is it the time you understand, the time the AI era is demanding, not the output. The things what you're working is an output. You have to work on the outcome. The output, between the output and the outcome is, as I said, as a network engineer, you have to deploy the two floor enterprise network, right? That is the output, you do it. The outcome is, you need to understand from the end to end what how many users sitting there, how the seamless connection I can provide, how the whole the end to end the starting from the bandwidth connectivity you have to take, starting from the security and everything. That is the outcome which you have to look out. If you're able to solve that, yes, definitely you are on the maybe the growth path, I can say. I worked as a data analyst for 1 year, and almost another year I worked in the same company, built an open chatbot based on yeah. If you already build the agent, so basically you have built a couple of things, right? What I suggest is to shake is try to solve the real time problem in your use case, what you see around. For example, you're data analyst in a XYZ company in the same domain. What you see around the problem, if you try to solve it through all your learning, since you already done the you learn about the patient reducer lung chain and the stuff. So try to solve the real use case, give the real outcome, which is production ready. It's a very simple. It's not very complicated. That is the thing. Reason I said it's move fast. Now I was hearing, I'll tell you the very one real example of how the things are moving so fast. If you see the latest, the Claude coder, right? The engineer, the person who built said he built this this whole, the Claude code production ready, service or the application in 10 days. The SEO hates so globally famous, the production ready system has built just in 10 days. Earlier, it used to be years to, build such a system. Uh, okay. Anything else? Maybe I'll have you already, I think those who are having a WhatsApp message, you have my LinkedIn connection. So feel free to drop your questions over there. I'll try to answer response as much I can, and I'll stay tuned through there. So maybe, yep. Slides. Shake slides. I think, yeah, I'll share it across to, I don't know how to share. I'll share it to the moderator. Let's figure out, maybe figure out how we can share further. I'm fine. I mean, slides, I don't see, I have put a lot of effort in the slides. I just use a couple of things which is there on my mind, and a couple of images I created from AI. Cool, good. Saif, are we good to close the session? Is there anything else on the closing notes? Good, good. Thanks for suggestions. Thank you all for having me today in this session. I hopefully we will cross our roads again in the future. Thank you all. Have a good day, everyone.